watching Simplify Your Concept.
Hello everyone, welcome back to part 3 of three-phase induction motor. Today we will try to understand the theory behind the production of rotating magnetic field, often called as RMF. We will try to understand how the magnetic field which is produced in the induction motor is rotating in nature. So let's get started. For this, first let us imagine the stator of the electric motor which has a three-phase winding. So this is the stator of the three-phase induction motor having the three-phase winding which are distributed in such a manner that each winding of each phase has 120-degree phase angle with respect to each other. So this three-phase winding is being excited by the three-phase supply. The three-phase current flows in the windings simultaneously and the currents are also displaced by 120 degrees from each other. If the phase sequence considered to be R, Y and P, then the three currents or the three-phase current produces the three fluxes phi R, phi Y and phi B, which are also displaced from each other by 120 degrees, as you can see in this figure. See, although the vector sum of the three currents, that is IR, IY and IB, will be zero in a balanced three-phase system at any instant, but the resultant of the magnetic field, that means phi R, phi Y and phi B, will not be equals to zero. Rather, it will have a constant non-zero value rotating in space with respect to time. So the magnetic flux which are produced by the current in each phase can be represented by their instantaneous equations, which is given here as phi r equals to phi m sine omega t, phi y is equals to phi m sine omega t minus 120 degrees, and phi b is equals to phi m sine omega t minus 240 degrees. So these are the instantaneous values of the fluxes, and phi m is the amplitude of the flux. So now this figure is the graphical representation of the fluxes, and from this we will try to find out the resultant fluxes for various instances. Let us first consider theta equals to 0 degree. So the instant considered here is 0 degree, and we know that omega t is same as theta, which is 0 degree here. So as we know the equations of phi r, phi y and phi b, and if I substitute the value of theta or omega t as 0, we are going to get the values of phi r, phi y, phi b, and using these three values, we will find out what is the resultant flux. Considering the equation of phi r as phi m sine omega t and using omega t equals to 0, this will give a mean 0 value. Talking about phi y, which is having an equation of phi m sine omega t minus 120 degrees, and if I substitute omega t equals to 0, the value I will get as minus 3 root 3 by 2 phi m. And phi b is phi m sine omega t minus 240 degrees. If I substitute omega t or theta equals to 0, I will get the value of phi b as root 3 by 2 phi m. We have got the instantaneous values of phi r, phi y and phi b at the instant theta equals to 0 degree. And using these equations, we are going to draw the vector diagram. Now as we know that this is phi r, this is phi y and this is phi b. Now if you see here, phi r value is 0. So I do not need this phi r, whereas phi y value is minus root 3 by 2 into phi m. So we have to get the minus value of phi y. So in order to get the minus phi y, we have to extend this phi y in the opposite direction. So this is minus phi y, which is having a value of root 3 by 2 phi m. And phi b is a positive value having a value of root 3 by 2 phi m. Now in order to get the resultant of this, so first we will complete this parallelogram, and then this is the resultant, which is phi t. So now let us mark here, let us take O, A, B, C. And this is basically a rhombus. So from D, I'm going to draw a perpendicular bisector on OA. Let me mark this as D. And this is going to divide the total resultant flux into two equal parts. And this angle is 30 degrees. So from the vector diagram, I can say that BD is the perpendicular bisector drawn from B on phi t. And I can write OD is equals to DA, which is equals to phi t by 2. Now considering the triangle OBD and taking cos 30, because this is a perpendicular bisector, so this angle is 90 degrees. So this triangle is a right angle triangle. So cos 30 will be equals to base by hypotenuse, so that is OD divided by OB. Now OD value, we know it is phi t by 2. And what is OB value? OB value is nothing but phi b, which is root 3 by 2 into phi m. Now let me consider here, see cos 30 value, we know it is root 3 by 2, which is equals to phi t by 2 divided by root 3 by 2 into phi m. So this 2 and 2 will get cancelled, and finally we are going to get 3 by 2 phi m is equals to phi t. Or I can say the value of phi t is 1.5 times phi m. So from this what we observe that the resultant flux is having a value of constant value of 1.5 times phi m, and its direction, if we observe, it is vertically downwards, as you can also observe in this case. So this is phi b value or phi y value, which is minus root 3 by 2 phi m, and this is phi b having a value of root 3 by 2 phi m, and this is the resultant flux, which is having a value of 1.5 times phi m. This is the magnitude of phi t, whereas its position, if you see, it is vertically downwards. So at instant theta equals to 0, the position of phi t is this. Now let's consider another case where theta equals to 60 degrees. Considering theta equals to 60 degree, we can again find the value of phi r, which will be equals to root 3 by 2 phi m. This comes after substituting the value of theta in the equation of phi r, which is phi m sine omega t or phi m sine theta. Similarly, phi y will give us minus of root 3 by 2 phi m, and phi b will be equals to 0. So this I have got it after substituting theta equals to 60 degrees. Now using this again, we need to draw the vector diagram. So how are we going to get it? Since phi r is having a positive value, so this is phi r, which is having a value of root 3 by 2 phi m. Phi y is having a negative value. This will be your minus phi y, which is having a value of root 3 by 2 phi m. And phi b is 0, so we are not going to plot it. See, this is your positive phi y. So in order to get the negative phi y, I have extended this phi y in the opposite direction. And phi b was actually here. So since its value is reading 0, so that is why we are not going to plot it. Now again, to get the resultant, we just need to complete this parallelogram and taking the resultant of it, which is phi t. So same procedure we need to apply. Draw a perpendicular bisector from, let's take O, B, A, C and D, and consider this angle as 30 degree. And if you consider this whole triangle, same equation we are going to get cos 30 is equals to OD divided by OB, which is again here half of phi t divided by root 3 by 2 into phi m. So on simplification, again we are going to get phi t equals to 1.5 times phi m. So if you see, observe here, the resultant flux vector is having the magnitude as same as in the previous case, that is 1.5 times phi m, but it is rotated through 60 degrees in the clockwise direction without changing the value. So initially, if you might have observed, when I considered theta equals to 0 degrees, the position of phi t was vertically downwards, right? Initially, when I considered, the phi t value was here. Now, when I considered theta equals to 60 degree, this resultant flux has also rotated by 60 degree in the clockwise direction, right? Without changing its magnitude. So the value of phi t has not been changed, but its position has been changed. Now let's see one more case where theta equals to 90 degrees. So here, if I consider theta equals to 90 degrees, the value of phi r will be equals to phi m. Value of phi y will be equals to minus half of phi m, and value of phi b will be equals to, again it will be also minus phi m. So from this, if I have to draw the vector diagram, I am going to get something like this. So this will be my phi r, which is having a value of phi m. Next, to draw phi y, so actually this is my phi y, this is phi b. So in order to get minus of phi y, we have to extend this in the opposite direction, and this is half of phi m. Similarly, in order to get minus phi b, I have to extend this in the opposite direction. So this is minus phi b, which is having a value of half of phi m. And to get the resultant of this, will be phi t, which is equals to 1.5 times phi m, right? So how do you get that? See, this is first you can simplify this. You can simplify this, and then you can simplify this parallelogram. So you will get one resultant here, you will get one more resultant here, and then finally if you take the resultant of these two, you're going to get this resultant. Okay, so this will give you root 3 by 2 phi m, and this will also give you root 3 by 2 phi m, and finally when you take the resultant of this will give you 1.5 times phi m. Right? So again you observe that the resultant vector, that is the flux, having the same value as 1.5 times, but it has rotated further by 30 degrees, right? So initially it was like this when I considered theta equals to 0 degree. When I considered theta equals to 60 degree, we got the resultant here. So at 60 degree, this was the value of phi t. This was the value of phi t at theta equals to 0 degree. And now when I considered theta equals to 90 degree, this is my resultant. Okay, so what conclusion we can draw from this? So the final conclusion that can be drawn here is that the resultant flux is of constant magnitude, having a value of 1.5 times phi m, right? So in each cases we have seen that the value of phi t was same. Now I have considered only 3 cases. We can consider any other phases. Like for example, we can consider theta equals to 60 degree, theta equals to 120 degree, theta equals to 180 degree, and so on, right? So in all the cases, we will always get the magnitude of phi t will be equals to 1.5 times phi m. And this resultant flux rotates around the stator at a constant speed. When I consider theta equals to 0 degree, the position of the resultant flux was different. And when I consider theta equals to 90 degree, it has rotated through 90 degrees. And that speed at which this resultant flux is rotating is called as the synchronous speed. And as we know that, what is the equation of synchronous speed? Ns equals to 120 f by p. So I hope this video had made the concept about rotating magnetic field in induction motor very clear to you. And that's all for today. Thank you so much for watching. See you in the next video.